In this video, we're going to have a look at the gradient of a line, which is the steepness or the slope of a line. Here we've got the graph of y equals x plus 1. And if we add in y equals 2x plus 1, you can see that the graph has changed. You can see that the steepness has changed from this one to this one. If I put in y equals 3x plus 1 now, this pink line here, have a look, you can see it's steep again. I'm going to add in y equals 4x plus 1, but before I do, I want you to have a think about where you expect that line to appear. This is 1x plus 1, 2x plus 1, 3x plus 1. So 4x plus 1, as you've probably already imagined, is going to be steeper again. So every time I increase these numbers over here, it increases the steepness of my line. Let's have a look at this next graph, y equals 1/2 x plus 1. Have a think about where that's going to be. Y equals 1/2 x plus 1. It's going to be less steep than the 1x plus 1. So the smaller our number, the less steep it is. The higher the number, the more steep. Now all of these lines are going in this direction here, all sloping off to the right-hand side. And all of the numbers in front of our x's are positive. What's going to happen if I put this one, y equals negative 2x plus 1 in? Where's that going to go? Let's have a look. Negative 2x plus 1 is putting the line sloping in the opposite direction. So all of these ones are positive steepness. These ones are a negative steepness. Now, instead of just saying that this line is steeper than the other one, we actually assign numeric values to our steepness. And the way that we assign the value is we look to see if we imagine this black line is a ramp going up a staircase. If we took the ramp away, every time we took a step forward, we would be going up one. One across, one up. One across, one up. So this black line, we would say, has a gradient equal to 1. Let's look at the pink one. Every time I take one step across, I actually need to go up 2 spots. One step across, 2 steps up. So this pink line has got a gradient equal to 2. The blue line, if I look, it's a bit hard to see amongst all the other drawings, but if I go across one here, I need to go up 1, 2, 3 spots. Across 1, up 1, 2, and if I'd continue my graph, it would be 3. So this blue line has got a gradient equal to 3. The green line, if I head over here, across 1, we're going up 1, 2, 3, 4 until we get to our line. So this green one has got a gradient equal to 4. 1, 2, 3, 4. This red line here, if I go across 1, I'm going up a little bit, but I actually don't know how far up I've gone. So what's the best way to do this is if I just keep extending like this until I know that I've gone up 1 spot. I've gone across 3 before I can go up 1 full step. So that means that each time I go across 1, I must be going up a third of the way, a third that way, another third, which makes this full step after three steps across. Okay, let's have a look a little bit further into this. Okay, with what I was just talking about before, I was saying that we look at how far up we go and how far across we go to measure our steepness. The mathematical way of saying that is that we look at the gradient and we use the words rise and run. Same thing, up and across. The rise is how far up we go. The run is how far across we go. So let's look at this line here, this first one. If I go across 1 step, I'm going up 2. Across 1 step, I'm going up 2. Across 1, up 2. So to work out our gradient, do rise over run. So the rise, I'm going up 2, I'm going across 1. So my rise over run is 2 over 1. 2 divided by 1 is just 2. This second one here is a little bit different. It's sloping back the other way, which we talked about a little bit earlier. But if I just choose a point that I know I'm going through, which is here, if I go across 1, I'm going up a little bit, I don't know what it is. Across 1, up a bit, I'm not going to guess. So I need to keep going across until I hit another point that I know. Let's do that one. So my rise is 1, 2, 3. My run is 4. So for my gradient, which is going to be rise over run, I'm going up 3 and I'm going across 4. So I've got rise over run, 3 over 4 as a gradient. The only thing we need to check now is because this one is sloping back in this opposite direction, we need to put a minus on it because it's heading in the opposite direction to this one over here. This is a positive gradient. This is a negative gradient. Now, if you were to look into a textbook and just copy out the notes from your textbook, you're going to get something like this, which is exactly what we've just been talking about, but it's much more confusing in the way it's presented. So just be careful of copying out slabs of notes from your book. But it's saying the gradient is the slope, and it talks about these rise over run that we've talked about. This is for our negative gradient, rise over run. But again, it's written in a fairly confusing way. This is something that you do need to know. Anything that is sloping in this direction, we say is a positive gradient. Anything in this direction is a negative gradient. If you've got a horizontal line, the gradient for horizontal lines is always 0, and the gradient for vertical lines is always undefined. So if you have any horizontal line, it's a 0 gradient. Any vertical line is an undefined gradient. This formula is a worldwide formula. Everyone uses it. You need to know that gradient is rise over run. Okay, let's have a look at some examples. We need to decide here whether the lines A, B, C and D on this graph have a positive, negative, 0 or undefined gradient. So let's have a look at part A, which is this one over here. It's sloping backwards. This is a negative gradient. Part B. B is this vertical line here. Looking back, any vertical line has an undefined gradient. So we say it's undefined. Part C is this orange one. It's a positive gradient. It's sloping toward the positive. And part D, which is the horizontal line here, that has a 0 gradient. Okay, so once we've got that worked out, we know which is positive, which is negative. We then need to assign an actual numeric value to our gradient. So let's have a look at some examples here. If you're asked to find the gradient for any line, there's a few steps you need to follow. And if you follow these lines, you're going to be right. First thing is you find 2 coordinates on the line that you know your graph goes through. So let's have a look at this one. I know it goes through the origin, and I know it goes through this point 2, 3. The next thing I do is join these coordinates using a right angled triangle. Okay, so let's go there, drop that one down until it meets this line. Next, find the rise and the run. So how far up have I gone? I've gone from 0 up to 3, and I've gone from 0 to 2. So there's my rise and the run. Next step, substitute into this formula. So I know that gradient equals rise over run, which is 3 over 2. And that's all you need to do. Let's do the next. Then you just need to check whether you can cancel down and whether it's positive or negative. This is positive, so we're right. We leave it as that. This one, let's follow the steps. 2 points we know we go through. Join it up with a triangle. My rise is 4, my run is 4. So my gradient is